Good morning, all of you. Today we will discuss the next part of photoelectric effect. Today we are going to discuss about how voltage is versus what is the voltage versus current graph and frequency versus current graph. So, in the previous class we have discussed that photocurrent is direct proportional to the intensity, and we also studied that to initiate current, intensity doesn't matter, it depends on the threshold frequency. Okay, so it depends on the frequency, lower frequency, threshold frequency. To initiate emission of electron, to initiate current, threshold frequency is required. And second thing we studied in the previous class, that after the initiation, after the flow of electron is started, then the current value depends on intensity. More the intensity, more will be the current. Today we will discuss how the photocurrent will be affected by the voltage and how the photocurrent will be affected by frequency. First studied voltage versus current graph, for this experiment. As we know, here voltage acts as a supporting agent, right? If we apply more frequency, electron will start emitting from this metal plate, but all the electrons have not equal kinetic energy. So some electron will reach this plate A and some electrons may not reach plate A. So here battery pushes the other electrons to reach this end, right? So battery is applying force to move these electrons from this plate to plate A. Okay, so initially in the absence of the battery also, some electrons may reach plate A. That means in the absence of battery also I can get certain value of current. But when I will apply this voltage and increase the voltage, gradually more number of electrons will reach plate A and I will get more and more value of current. That means when I will apply battery and increase the battery, I will get more and more current. So let us understand from a table. Suppose initially I have given 10 volt potential and I get certain 10 ampere current, for example. Okay, then I increase the voltage to 20 volt and I get suppose 15 ampere current. Suppose I increase the 30 volt and I get 20 ampere current. Then 40 volt and again I get 20 ampere current. 50 volt, again I get 20 ampere current. From this voltage and current photocurrent graph table, what I observed, initially when I am increasing the voltage, at the same rate current is increasing. When I increase the voltage, current is increasing. Increasing the voltage, current is increasing. But here again I am increasing the voltage but the current is not increased. Here I increase the voltage but current is not increased. Why so? Look, initial starting phase we know that if we increase the voltage we can get current. Why? Because we have understood that here battery will push the electrons. If we increase the potential, that means it will push the electrons more forcefully. By increasing the potential, it will push the electrons more forcefully. So more and more electrons will reach plate A. So I will get ultimately more current. But here what happens? Why the current value is not increasing? We are increasing the voltage here, but the current value is not increasing. Why? Look, here as we know, every metal have certain fixed number of electrons. Suppose I will say iron or any metal. All the metals are made of atoms, molecules, right? Suppose I will take iron metal atom, one atom of iron. It has fixed number of electrons, right? suppose I will provide it some potential. Okay, initially suppose 20 electrons are emitted, then or more 20 electrons are emitted. Like this, if I will increase the potential, if I increase the potential gradually, more and more number of electrons will emit from this atom. At a stage comes when all the electrons from this iron will emit. It will have no more electrons. I am increasing the potential gradually, and I observe that gradually the number of electrons emitting from this atom is increased. After certain value of potential, suppose I'll say after 15 volt, I'll say that all the electrons of these atoms are emitted. जितने इसके पास इलेक्ट्रॉन्स थे सभी एमिट हो गए. अब अगर इससे अब 25 वोल्ट कर दूं तो इसके पास तो ज़्यादा इलेक्ट्रॉन्स है ही नहीं, राइट. तो उससे जो इलेक्ट्रॉन्स और उससे ज़्यादा इलेक्ट्रॉन्स से इसे एमिट नहीं होगा. सपोज इसके पास सपोज 56 इलेक्ट्रॉन्स थे. 15 वोल्ट के मैंने जब 15 वोल्ट दिया तो 56 इलेक्ट्रॉन एमिट हो गए. 56 इलेक्ट्रॉन्स सारे के सारे एमिट हो गए थे. तो 56 इलेक्ट्रॉन से मुझे जितना करंट मिला था मैंने मेजर कर लिया. सपोज 56 इलेक्ट्रॉन से मुझे करंट कितना मिला, 2 एम्पेयर करंट मुझे मिल गया था, राइट. अब मैंने इंक्रीज पोटेंशियल को इंक्रीज करके 25 वोल्ट कर लिया. ओके, 25 वोल्ट में कितने इलेक्ट्रॉन एमिट होंगे, वही 56 इलेक्ट्रॉन एमिट होंगे. क्यों? क्योंकि इसके पास तो वही 56 इलेक्ट्रॉन ही थे ना, इससे ज़्यादा तो इलेक्ट्रॉन है ही नहीं इसके पास. तो चाहे आप 15 वोल्ट करिए या फिर 25 वोल्ट करिए तो आपको कितना इलेक्ट्रॉन मिलेंगे, 56 इलेक्ट्रॉन्स ही मिलेंगे. तो 56 इलेक्ट्रॉन से जितना करंट मिल रहा था अभी भी उतना ही करंट मिलेगा. तो 15 वोल्ट में आपको जितना करंट मिल रहा था 25 वोल्ट में भी उतना ही करंट मिलेगा. इसीलिए देखिए यहाँ पर 30 वोल्ट में जितना करंट मिल रहा था 40 वोल्ट में उतना ही करंट मिल रहा है, 50 वोल्ट में उतना ही करंट मिल रहा है. दैट मीन्स इट हैज़ नो मोर इलेक्ट्रॉन्स टू एमिट. अभी इसके पास और ज़्यादा इलेक्ट्रॉन्स ही नहीं है. इस चाहे आप वोल्टेज जितना भी इंक्रीज कर लीजिए उतना ही इलेक्ट्रॉन्स मिलेंगे, उतना ही करंट मिलेंगे. तो क्या होगा मेरे लिए, करंट अब भी इंक्रीज नहीं होगा. करंट का एक सैचुरेशन वैल्यू आ गया. तो करंट का सैचुरेशन वैल्यू, इट इज़ द सैचुरेशन वैल्यू ऑफ करंट. It is the saturation value of current. I am again repeating the whole process. Initially when the battery was not provided, I was getting some little bit current. When I inserted the battery and increased the potential gradually, I observed that due to the presence of potential, due to the presence of battery, the value of current is increased. After certain value of voltage, the current becomes saturated. Current is not increasing again. Now what the scientists did, they observed that अभी तो भाई चाहे बैटरी कितना भी पोटेंशियल कितना भी इंक्रीज कर लीजिए करंट तो नहीं बढ़ेगा. उन्होंने क्या किया, बैटरी को उल्टा कर लिया. ओके, बैटरी को उल्टा करके लगा लिया. तो उन्होंने क्या किया भाई, इस साइड पॉजिटिव और इस साइड नेगेटिव कर लिया, राइट. अब ये साइड हो गया मेरा पॉजिटिव, ये साइड हो गया मेरा नेगेटिव. तो क्या होगा देखिए, जो प्लेट सी नाउ इट इज कनेक्टेड टू द पॉजिटिव पोटेंशियल, सो इट विल बिकम पॉजिटिव पॉजिटिव पॉजिटिव. नाउ प्लेट ए इज कनेक्टेड टू द नेगेटिव पोटेंशियल, सो प्लेट ए विल बिकम नेगेटिव, राइट. तो पोलैरिटी ऑफ द प्लेट हैज बीन चेंज्ड. पोलैरिटी इज चेंज्ड नाउ. इफ द पोलैरिटी इज चेंज्ड बट plate C is my photosensitive plate and the light is falling on plate C, and when light is falling on plate C, look, light के पास एनर्जी है, ये जाके गिर रहा है, गिरने से क्या होता है, इलेक्ट्रॉन्स एमिट हो रहे हैं, इलेक्ट्रॉन यहाँ से निकल रहे हैं, राइट. कुछ हर एक इलेक्ट्रॉन का कुछ काइनेटिक एनर्जी है. ईच इलेक्ट्रॉन हैज सर्टेन काइनेटिक एनर्जी, बट दिस इज माई पॉजिटिव प्लेट, so it will try to attract the electrons. It is my negative plate, it will try to repel the electrons. So what will happen here, there is obstacle in front of the electrons. Electrons cannot move freely from plate C to plate A. Okay, electrons can move from easily from plate C to plate A. Okay, now what will happen? If we increase the potential now, if we increase the potential here, but it's reversed now. If we increase the potential, the plate C will attract these electrons more and more. This plate A will repel these electrons more and more. So what will happen? Gradually less number of electrons will reach plate A. So gradually in the circuit I will see a decay in the value of current. That means if I draw the table, in this table I can see if I increase the potential negative direction, suppose I will say 5 volt, minus 10 volt, minus 20 volt, minus 15 volt, minus 20 volt, minus 25 volt. In this way, if I increase the potential in the negative direction, what I will observe? I will observe that the current value is decreasing. Suppose in 5 volts, suppose I am getting 5 ampere current or 5 microampere current, and in minus 10 volt I am getting 4 microampere current, 15 volt I am getting 3 microampere current, here 1 microampere current, here 0 microampere current. Gradually the value of current will decrease and it will become 0 at certain voltage. Okay, that means at 25 volt, no electrons is capable to reach plate A. No electrons has such kinetic energy to reach plate A, because देखिए C इसको खींच रहा है इधर और A क्या करे, उसको धक्का दे रहा है, रिपेल कर रहा है, तो इस इलेक्ट्रॉन के पास अभी कोई एनर्जी ही नहीं है कि वो यहाँ पहुँच जाए, ए के पास पहुँच जाए और मुझे करंट मिले. दैट मीन्स हियर ऑल द इलेक्ट्रॉन्स, none of the electrons can reach plate A. So this voltage is called your stopping potential. Stopping potential. What do you mean by stopping potential? Stopping potential. What it means? Stopping potential means the potential, the voltage at which all the electrons stops. None of the electrons can reach plate A. It is the potential at which none of the electrons can reach plate A. Okay, this is called stopping potential. At stopping potential, the current in the circuit is 0. Current in the circuit is 0 at stopping potential. Stopping potential is symbolized by V naught. It is symbolized by V naught. Okay. जो ये कब स्टॉप होगा? इलेक्ट्रॉन कब स्टॉप होगा? जब यहाँ से जो रिपल्सिव फोर्स है इस काइनेटिक एनर्जी के बराबर होगा. देखिए, इलेक्ट्रॉन इज मूविंग इन दिस वे एंड this potential is trying to oppose the motion of electron. This reverse potential is trying to oppose the flow of electron. When the electron will stop? कब स्टॉप होगा? जब इस opposing force इस एनर्जी के बराबर होगा. जब इसका पोटेंशियल एनर्जी इसके एनर्जी के बराबर होगा. दैट मीन्स व्हेन द स्टॉपिंग पोटेंशियल एनर्जी इज इक्वल टू द काइनेटिक एनर्जी ऑफ दिस इलेक्ट्रॉन. सो आई कैन से maximum kinetic energy of electron, maximum kinetic energy of the electron equal to stopping potential. Maximum kinetic energy of the electron equal to stopping potential. Here that means we know this my potential energy, we know na, W equal to QV, here V equal to V naught, Q equal to E, charge of electron. So here we observe that it is very important equation, that is half, that means maximum kinetic energy equal to your stopping potential energy E V naught. Okay, from all we have studied, if I draw the graph, what do you observe? That initially in the absence of V also, there is some current here. V versus I graph, we will draw V versus I graph. In the when voltage was 0, I was getting some value of current. Then I increase the voltage and I get I can observe increase in value of current. Then at certain point, after certain voltage, I will get saturated value of current. The current value is not increasing here. Current value is not increasing. After certain value of voltage, the current is not increasing. Okay. So what I observed, I am repeating again. At 0, I get some current. If I increase the voltage, I will get there is some increase in current. After certain value of voltage, the value of current is not increasing. I am saying it is my saturated value of current. Then again, if I reverse the potential and increase it gradually, what will happen? The value of current will decrease, and at certain voltage called V0, the value of current will become 0, and this voltage is called your stopping potential. So graph between voltage and current will look like this. This is the graph of voltage versus current. Second, let us start frequency versus current graph, photocurrent graph. Frequency versus photocurrent. Frequency versus photocurrent. We know that frequency depends on color of the light. If we change the color of the light, the frequency will change gradually, right? So we observe that when we are changing the color, we are changing the frequency. That means energy of the light is changing. Energy of light equal to energy of light is equal to H into nu. H into nu. That means it is related to the frequency. If we increase the frequency, energy of light increases. Energy of light, incident light, will also increase. That means if we are changing the color of the light here, then we can change the energy of the light. Okay, तो क्या होगा? देखिए, suppose I will apply red color. That means it has low frequency. The light has low energy. So what will happen? It will fall. The light falling on this plate has low energy. It does not have sufficient energy to move the electrons from this metal plate. If I increase the frequency, that means suppose I will say I am applying violet color. I know violet color has more frequency. That means it has more energy. When this more energy light will fall on this metal plate, so what will happen? It can emit the electrons. Again, if I increase the frequency more and more, some other color I will take, and suppose beta, which has more frequency than violet color. Suppose beta is the color of light which has more frequency than violet. So the electrons emitted by this beta has more energy than this electron emitted by violet. What I am saying, again repeating it, I have two electrons. One electron emitted by this violet color, one electron emitted by this beta color. As we know, beta has more energy. It has more energy. देखिए, दो बच्चे हैं मेरे पास. ओके, एक बच्चा दुबला पतला सा, दूसरा मोटा मोटा बच्चा है. चलिए, ये क्या करेगा? एक बॉल को धक्का देगा, दूसरा एक बॉल को धक्का देगा. तो कौन कौन सा बॉल ज़्यादा तेज़ी से भागेगा, आगे जाएगा? आंसर इज दिस बॉल, बिकॉज इसने जोर से धक्का दिया था, राइट? इसने जोर से धक्का दिया था, तो इसके पास जो एनर्जी होगा, इस बॉल के पास जो काइनेटिक एनर्जी होगा वो क्या होगा, ज़्यादा होगा। उसी हिसाब से यहाँ पर मैंने क्या किया है, 2 एक्सपेरिमेंट किया है। पहले एक्सपेरिमेंट में हमने क्या किया था, वायोलेट कलर, सेकेंड में बीटा कलर। बीटा हैज मोर फ्रीक्वेंसी देन वायोलेट कलर, सो इलेक्ट्रॉन्स emitted by this violet color has less energy as compared to electrons emitted by this beta color. Okay, so if we increase the frequency, electrons emitted from this frequency has more energy, they will gain more energy. That means I can say more frequency means more energy. Okay, more frequency means more energy. If this electron has more energy, to stop this I have to apply more potential, right? That means suppose यहाँ पर सेम एग्जाम्पल लेते हैं, दुबला पतला सा बच्चा, मोटा वाला बच्चा, दोनों ने बॉल को किक किया, तो ये धीरे जाएगा, इसके पास, इस बॉल के पास लेस काइनेटिक एनर्जी है और इस बॉल के पास मोर काइनेटिक एनर्जी है। इसको स्टॉप करने के लिए क्या करना पड़ेगा, मुझे ज़्यादा ताकत लगाना पड़ेगा, और इसको स्टॉप करने के लिए मुझे कम ताकत लगाना पड़ेगा। सिमिलरली यहाँ पर 2 इलेक्ट्रॉन हैं, ये बीटा वाला इलेक्ट्रॉन, ये वायोलेट कलर वाला इलेक्ट्रॉन, तो इसको स्टॉप करने के लिए मुझे कम पोटेंशियल देना पड़ेगा और इसको स्टॉप करने के लिए मुझे ज़्यादा पोटेंशियल देना पड़ेगा। इसीलिए जो स्टॉपिंग पोटेंशियल क्या होगा, चेंज हो जाएगा। तो ग्राफ जो बनेगा, फ्रीक्वेंसी वर्सेस करंट ग्राफ क्या होगा, देखिए आपका करंट तो इधर ऐसा रहेगा, आप चाहे जितना भी आप फ्रीक्वेंसी चेंज कर लीजिए, लेकिन आपका जो सैचुरेटेड वैल्यू करंट है, सैचुरेटेड करंट, ये चेंज नहीं होगा। क्यों? क्योंकि जो करंट है किसके ऊपर डिपेंड करता है, अमाउंट ऑफ करंट डिपेंड्स ऑन इंटेंसिटी, बट टू स्टॉप दिस इलेक्ट्रॉन we require more potential. So if I'll say it is frequency in nu1, frequency nu2, frequency nu3, and nu1 is less than nu2 is less than nu3, that means stopping potential of 1 will be less than stopping potential of 2, less than stopping potential of 3. That means stopping potential depends on frequency. More the frequency, more the stopping potential. So graph between current and frequency will look like this. Thank you for today's class.